Okay, hello students. Today we will learn trapezoidal rule. We have already discussed the trapezoidal rule and now I will just show you quickly the method because we had a Zoom recording but it was a big video, so it is better to share with you a compact video. Now, the book that we have been following for the course of numerical computations is Stephen C. Chapra, Numerical Computations Methods for Engineers. And chapter number 21 is about the numerical integration, right? So, chapter number 21, the trapezoidal rule. We discussed the trapezoidal rule. Here you can see the single application of trapezoidal rule, and when we apply it on multiple times, basically when we talk about numerical integration, we are talking about area under the curve. And when we divide it into rectangular parts and we find the area under the curve, then we say that, for example, here you can see the rectangle and the width and the height. So this is the graphical interpretation of the trapezoidal rule. And when we have multiple applications, then we will have a standard formula, and we can see that this standard formula is here. Equation number 21.10. We will strictly follow this formula for the application of the trapezoidal rule. Let us understand it quickly with the help of an example. Let me say that I have a function f of x is equal to 1 plus exponential of x. Next, I'm saying that the starting point, the lower limit of integration is 0, and I'm saying that the upper limit of integration is 4. I'm saying that the step size is 1. And then how many patches are there? The formula is B minus A divided by H, which will give me 4. Now remember that n plus 1 is equal to number of grid points, right? So now students, we will write the formula for the trapezoidal rule. Remember that for the formula we have either b minus a divided by 2n or h by 2. Both have the same meaning. Then the functional value of at a plus 2 times functional value at a plus h plus 2 times functional value at a plus 2h plus 2 times functional value at a plus 3h plus functional value at a plus 4h. Now the question is that what is the functional value at a plus 2? What is actually, let's say, what is actually a plus 4h? It is actually a plus nh for this special question, for this specific question. And when we substitute n here for, we will get a plus b minus a is equal to b. All right, so this thing you can also write a plus nh, or you can write here b. Okay, and remember that now I have the functional values at 1 2 3 4 5 5 points because I had 4 patches, and at the boundaries I have the coefficient 1, and at the intermediate points I have the coefficients 2 2 2 2, right? And we did it in the classroom and we obtained the answer, the integral. And now let me show you the M file and how to implement it, because I believe that you are facing difficulty. So I have shared with you the M file. You can see the first command is about the outputs and the inputs. Trap Z1 is the name of the file or the function. H is the step size. X of 1 is equal to A. X of n plus 1 is equal to B. You have two loops here, two for loops here, nested loops. Why? Because you are first specifying the x values, then you are specifying the corresponding y values. For example, if you have x is equal to 0, you will find f of 0. And then you have x is equal to 1, you will find f of 1. All right, so this is the meaning of this nested loop. Now you will write the numerical integral formula here, and you can see here that here you have the step size times divided by 2 means 0.5 times h, and then you can see here that 2 times intermediate points, and then f of x of 1 and f of x of n plus 1. That is the last point and the starting point. That is it. Save this m file. Okay, save this m file. Always remember that. Let's say that I'm going to make this a new m file, then always remember that click on the floppy button, and then remember that documents MATLAB folder and save it with a unique name. All right, otherwise MATLAB will overwrite it. Okay, and there will be a clash and it will not run successfully. So now I will type here my function. So I have got y is equal to at the rate of x 1 plus exp of x. Then I will have the trapezoidal rule. So I will write here trapezoidal rule 1. Now I have this m file. Please make sure that you have this m file ready. You can see traps 1 here. So that's why I'm calling it here in the command window. This is the command window. That was the editor. This is the starting point 0. This is the ending point 4. This is the number of iterations. And this is my function. Okay, this is my function. So now I will press enter, and I will get the numerical answer, numerical integral 61.9919. And you can do it manually using this formula, and you can obtain the answer. Now the task for this week is that you will solve one question from the exercise. I believe I have given you third question from the exercise. First, you will do it by hand for single application and for different values of n. Remember, trapezoidal rule is valid for all values of n. Next, we will learn Simpson's rule, and we have a restriction for Simpson's rule for the step size. We will discuss it later, but for the trapezoidal rule, it is applicable on all values of n. Now, remember that we also need to think about the error analysis. Okay, so we will think about the error analysis. I will see you later with the next method, Simpson's rule. All right.